Hello students, how are you? I hope that you all are well. Our school is providing you this digital content by which you can continue your learning from your home. This video is sponsored by KPS CONVENT and its aim is to educate your child for meaningful life. Here is the second chapter of class 7, that is the flow and the measurement of heat. In this module, we are going to learn about temperature, the relationship between different temperature scale and the different method of heat transfer. Let's start the chapter with eye connect. You have to do it by your own self. Pause the video, do it first, then we will continue our session.
Temperature and different temperature scales. How can you measure the warmth of coffee in a cup or the coldness of an ice cube? Temperature is the measure of the hotness or coldness of a substance. We measure temperature in degrees using a device called a thermometer. There are different scales to measure temperature. Let's learn about the different temperature scales. Temperature is measured in three different scales: Celsius scale, Fahrenheit scale, and Kelvin scale. The commonly used scale of temperature is the Celsius or centigrade scale, denoted as degrees Celsius. It was developed by Anders Celsius. In this scale, 0 degrees Celsius is the melting point of ice and 100 degrees Celsius is the boiling point of water. Between 0 degrees Celsius and 100 degrees Celsius, the scale is divided into 100 equal divisions. In the Fahrenheit scale, temperature is denoted by degree Fahrenheit. It was developed by Daniel Gabriel Fahrenheit. On this scale, the freezing point of water is 32 degrees Fahrenheit and the boiling point of water is 212 degrees Fahrenheit. There are 180 equal divisions between 32 degrees Fahrenheit and 212 degrees Fahrenheit. How can we compare the divisions on the Fahrenheit scale with those on the Celsius scale? 180 divisions on the Fahrenheit scale equals 100 divisions on the Celsius scale. 1 division on the Fahrenheit scale equals 100 by 180 divisions on the Celsius scale, which is equal to 5 by 9 divisions on the Celsius scale. Scientists use a scale that is different from the Celsius and Fahrenheit scales. They use the Kelvin scale, which is denoted by K. It was invented by Lord Kelvin. On the Kelvin scale, the freezing point of water is 273.15 Kelvin and the boiling point of water is 373.15 Kelvin. The degree symbol is not used in the Kelvin scale. The SI unit of temperature is Kelvin. Similar to the Celsius scale, the Kelvin scale is divided into 100 equal divisions between the freezing point and the boiling point of water. To sum up, temperature is measured using a device called thermometer. The three different temperature scales include Celsius scale or degree Celsius, Fahrenheit scale or degree Fahrenheit, and Kelvin scale or Kelvin. The Celsius scale is divided into 100 equal divisions between 0 degrees Celsius and 100 degrees Celsius. The Fahrenheit scale has 180 equal divisions between 32 degrees Fahrenheit and 212 degrees Fahrenheit. The Kelvin scale is divided into 100 equal divisions between 273.15 Kelvin and 373.15 Kelvin. Methods of heat transfer. Two friends, Rita and Anita, go to the beach on a sunny morning.
Ouch! The sand is so hot.
Yes,
It's burning my feet too. The sun is almost 150 million kilometers away from the earth. I wonder how it heats the sand on the beach from so far away.
We know that heat travels from hotter to colder objects. But how does this happen? Let's find out. When we leave one end of a steel spoon dipped into a pan with food cooking in it, soon the other end of the spoon starts to feel warm. How does the heat travel from one end of the spoon to another? Spoon, like all other matter, is made of particles. As one end of the spoon is dipped into hot liquid, the particles near the liquid gain the heat energy and start vibrating. These vibrations cause other particles to vibrate and so on. This is how heat from the hot end of a spoon travels to the cold end. This process of heat transfer, which takes place because of contact between objects, is called conduction. It happens mostly in solids, specifically metals. This is because particles are tightly packed in solids, and the vibration of one particle can cause others to move because of lack of space. Hot air is lighter than cold air and hence rises up. Fire is used to heat the gas filled in hot air balloons so that they reach high up in the sky. How does fire at the base of the balloon heat up the gas in the entire balloon? As the fire is blasted, the particles of air around the flame become hot and rise up. The particles of cold air rush down to take the place of the hot particles. As these cold particles surround the flame, they gain heat energy and rise up as well. More particles of cold air then rush down to take the place of these hot particles. The cycle continues and heats up all the gas inside the balloon. This process of heat transfer, in which particles move towards and away from the source of heat to cause heat transfer, is called convection. It happens mostly in liquids and gases because their particles can move freely. Anita wondered how the sun, from almost 150 million kilometers away, manages to heat the sand on the beach. The heat of the sun travels to the earth in the form of waves. These waves do not need a medium to travel in. When these waves hit a surface, the heat energy in the waves gets released and heats up the surface, in Anita's case, the sand. This process of heat transfer, which does not require a medium, is called radiation. We now know that heat gets transferred from hot objects to cold objects through conduction, convection, and radiation. For conduction, the object needs to be in contact with the source of heat and takes place mostly in solids. Convection takes place in liquids and gases when the particles move towards and away from the source of heat. Radiation does not require a medium to transfer heat.
Question time, students. So your question is, why should we wear cotton clothes during summer? Thank you, students. I hope that you all enjoyed the video. Stay connected. Till then, bye-bye.